Hi, I'm Patrick Roberts, and today I'm going to teach you how to implement observables with friend injection. So first we need to understand what observables are. Observables are a stream of events in a push-based model. So this shows a stream at the top half, and then an observable operator that performs a transformation on that stream to push a different stream of events downstream to a observer or subscriber. So these are a few examples. In pairwise, you can see that it doesn't immediately emit an event. It waits for the second event to arrive before it can emit the pair. And then every element that arrives thereafter, it's emitting a moving window of every other element, or every adjacent elements, two elements. With the map, it's just like a transform, and filter is a filter. So those are pretty straightforward. So what do observables look like in C++? So here's an implementation of something that looks very similar to using the ranges library, but the fundamental difference is that ranges are pool-based and observables are push-based. So in this, we create an observable called iota that pushes the elements 0 through 9 downstream to transform, which squares it, and then to filter, which keeps the odd squares, and then we print all of those results as they arrive. And so we get this output in our console, all of the odd squares from 1 to 9. So let's implement pairwise. So this is an interesting one. So pairwise, as I explained it, it accumulates, so it has to wait for some data to arrive, and it does an accumulation as it emits data downstream. And so we want to get this sort of output from this code. So it should be fairly straightforward. We need to implement an operator that takes the callback that we need to invoke with the sequence of values. So it's going to look something like this. And so one way that we can perform that conditional logic is we can use a variant. So in the variant, we declare our state as a variant of monostate when we have no objects yet, the item type when we have one object, and the pair type when we have two. And when we have one object and we get the next one, we can start emitting a pair. And when we have a pair and we get the next one, we can update that pair and emit it at the same time as well, which is why the last two overloads call next, but the first one does not because it's still accumulating. So does anyone see anything wrong with this?
The state.emplace item.second, won't you be referencing it if you take it at the wrong time?
No, that's actually fine. You can update the variant if it's captured by reference in the callback. That's not the issue. Anyone else? So the problem is the state is inside of our callback that is invoked per item. So we're not actually accumulating anything. We're just initializing a new state object every time we get a new item. So we need to move that outside. But now we can't just decal type value to get our item type. How the heck do we get that? And so we need to define a type trait that allows us to get that item. And this type trait is somewhat magical. So we need the observer type, or sorry, the observable type, and then get whatever the item that it emits to the observer. So in this case, like the iota, the type of the observable is the outer box, and the type that we're interested in is that I right there. So we need a type trait that transforms from the outer box to the inner. So friend injection. Let's define an observer that defines, and it has an operator that you can invoke it with. And when it is invoked, it instantiates a template that defines a friend function whose return type ends up being a type identity of the item. It's very weird because the friend declaration is in the key type, and the friend definition that's in struct set actually corresponds to the same friend function. And so when we force the instantiation, when we check if it's an observable, we can then do decal type of the ADL function call and get the dependent member type. And now that we have that and working, we can get this output. So thank you.